Hello. So in this equation there is a point mass of mass m and the initial speed is u. It is being projected at an angle 45. So obviously it is being projected, it will follow the parabolic path. So we have to calculate the angular momentum of this point mass about point O, or let's call it P, about point P, this is the initial point, after this much time. Okay. So we have to calculate what will be the angular momentum of this point mass after this much time. Now, to calculate the angular momentum after this much time, we have to see where will be this particle after this much time. What will be the location of this particle after that much time, and what will be its velocity? Because see, at every point of time, we know the velocity along the horizontal axis will always remain u cos theta, which is u by root 2. And if I get the vertical component, that will also be u sin theta, which is u by root 2. So that will be the component. The horizontal component during the parabolic motion remains same. It does not change. The vertical component keeps changing. So first thing we want to calculate what will be the vertical component after this much time. So for that, let's use the kinematical equation, and that to the first one. Okay, and the equation is V is equals to u plus at, that too in vertical. So the final velocity will be equals to initial velocity, which is u by root 2 in upward direction. Let's call that upward direction as positive. U by root 2 j cap, positive j cap, minus of gt j cap, because the acceleration due to gravity is in the downward direction. That's why I'm taking the minus. So that value will be u by root 2 minus, let's put the value of t, that is u by root 2 times of g j cap, and that value becomes 0. So velocity along the y-axis after this much time is going to be 0. So that tells us something, meaning after this time the particle is going to be at the topmost point, and it will be moving with this velocity u by root 2. And the height, we have a formula for height also, and if we want to calculate that height separately also we can calculate. So let's use the formula directly. H max is nothing but u square sin square theta upon 2g. That's the formula. Let's put the values. So u square sin square theta, sin theta is sin 45. That will be 1 by 2 divided by 2g, and that becomes u square upon 4g. That becomes the height. So let's extend the momentum. At the topmost point, momentum of the particle will be m into v, which is mu upon root 2. If I extend the momentum and I put a perpendicular with respect to the initial location, that is going to be the h max. So if you remember how to calculate the angular momentum, so angular momentum for this point mass about point P will be equals to magnitude of linear momentum, that is mu by root 2, multiplied with this perpendicular length, which is h max. And you see, if I hold the axis by the left hand and if I move the momentum, this thing is going to be the clockwise, and the clockwise means inside. For me it is inside, for you it is outside. So in this direction it is going. So I'll just show that this is the direction. Let's put the value of h max also. So mu upon root 2 multiplied with u square upon 4g. That makes mu square upon 4 root 2 times of g. That becomes the clockwise angular momentum of this particle after this time with respect to the initial location. Okay. So that's how we solve the equation. We have to first check where will be that particle, and we have to get the velocity there. Then after we get the velocity, we get the linear momentum. Then we have to extend that linear momentum, and we have to put the perpendicular with respect to axis onto that, which in this case became h max. Okay, that's how we solve it. Thank you.